Thank you, Yicheng. Welcome, everyone. I don't know if I can compete with that raffle, though. Actually, I'm going to need you to sell some tickets to pay for this array here. This is great to be here. I've been teaching this term, so I inflicted a final on my coastal oceanography class this morning. But at 8, we were in the intertidal at Seal Rock. But I'm getting to see what all of you get to do every day. Go to the intertidal, do science, talk to each other. So great community. So this is just going to be an eclectic talk about ocean observing and just some of my perspectives since I've been doing this for almost 2 decades. And some of you younger folks will see that you need perseverance to make this stuff happen. I'll show you some of the timing. And I say beneath the waves because we've had really good view of the ocean from satellites for quite a while now. And we've learned a lot about eddies and chlorophyll distributions, and we can track things with satellites, but it's really getting under the water that's the hard part. So that's the beneath the waves part. And this still remains one of my favorite photos of Cape Perpetua onshore of Hecate Bank, which we'll see next week. But it just shows the open ocean, blues and purples, through the productive green coast and all the way up to shore, the inner shelf or littoral zone with sediment. So this is going to be a mixture of motivation, what the array is, and some results. And along the way, encouraging you to get involved, use the data. So a lot of this audience, I don't need to say a lot of these things about the importance of the ocean, but it's just really nice to reemphasize it again. Some of these facts are maybe just a little bit. We know that it's not really half of the carbon. It's maybe more like a quarter to a third that's absorbed, but really important function. There's hazards, vast repository of living and non-living resources. Touches everyone. I can't have this week without giving a quote. This is from John Kennedy. And he gave this at the, actually I put my glasses on, the Dinner for the America's Cup in September 14th, 1962. And I bet a lot of you have seen this, right? About our connection to the ocean. And the fact that we have the same percentage of salt in our blood that exists in the ocean. So he's talking about this connection we all have. We are tied to the ocean. And when we go back to the sea, whether it is to sail or to watch it, we are going back from whence we came. So why am I showing this? Not only the connection to the ocean, but 2 days earlier he gave his moon speech. And so we're celebrating the 50th anniversary in 2 days. So I think with that challenge to the nation to explore and go to the moon, we're still playing out this challenge to explore and go to the ocean. So all of you young folks, join us. It's really important. So here's some of the things the ocean provides and why we want to pay attention, why we want to watch beneath the waves. These are just some local photos that some of you may recognize. And just a reminder of our particular piece of ocean. This is the California Current. I'll talk about the Northern California Current. It's one of 4 major upwelling systems. 1% of the surface area, but greater than 20% of the wild-caught seafood. Super important. And we're able to do comparative studies in our system and compare them to our cousins and see, how things are changing over time. So as a physical oceanographer, I always like to start with the forcing mechanisms. This is the wind over the North Pacific. This particular time of year, this is the July average. This is the pressure. And we know that the geostrophic flow in the atmosphere is with high pressure on the right as you face in the direction of the wind. And that gives us those strong upwelling winds along the coast. And then, of course, we're on the far side of the North Pacific Current or the West Wind Drift. It splits, goes in either direction. So this is kind of the background. Classic wind-driven upwelling, where we've got strong coastal jets, offshore Ekman transport, supply from below of cold, nutrient-rich deep water. And a lot of my career has been looking at all these crazy patterns. So temperature on the right, notice it's colder off Blanco. Anybody know why that is? Why is it colder down there? What's stronger down there than here?
Wind.
Yeah. It's actually pretty benign around here. If you go down there, it's tough to get out to sea. There's something we call curl-driven upwelling, where the wind is stronger in one place than the other. The Ekman transport is sideways to that, and we have to fuel it from below. So it just gives an additional push to the upwelling. Then there's all this crazy meandering here. This particular one is going around Hecate Bank. That's what makes that place so special. So come next week and we'll talk more about that. On the left is the coastal ocean productivity, false color image of milligrams per meter cubed. So again, one-for-one correspondence with the physics, Hecate Bank being a particularly amazing place. It's not really red like that. Can you guys see with these lights on? Can we turn off the first bank? Is that better? Wow. Good? Okay. So who's seen a plankton bloom like this offshore? What is that? Good stuff, bad stuff? Good stuff. So don't let people tell you that it's red tide or something. I think that's Bruce Menge's gang collecting on the rocks down there at Port Orford. Okay, so now let's look at this system in a cross-section. We know there's upwelling. We do know that water is low in oxygen. It's high in CO2. So we're starting to see that water pulled right up near shore and affect some of our inner shelf ecosystems, both in the driving some hypoxia that's up here, and now we're seeing lower pHs coming right to shore. So these are all reasons we really want to keep track of what's going on. We've shown these pictures over the years, a healthy community on the left, and then what happened in July of 2002, and then anoxic time in 2006. And then just to drive home the ocean acidification impacts, this is the effect on the shellfish. So in the oyster hatchery at Whiskey Creek, there was failure of the baby oysters to develop. And we now know that's because of the low pH waters. Okay, so lots of reasons we need to do a good job of watching what's going on out there. And I can tell you that in the 15 plus years I've been doing this, we've been using all these as arguments for why we ought to be doing something here. I always say that, the weather's great in San Diego, but not much is happening down there. All the action's up here. Jet streams coming across us, wobbling back and forth. We're getting big interannual variability. With climate change, all that stuff is marching north. You all know we get reversing winds. In fact, this summer seems like there's been a lot lately. Every time I come out to teach, the wind turns off. I think it knows I'm coming out. Okay, so what do we know about beneath the waves? And again, this is one of my favorite pictures of Wayne Burt. I don't know if you guys can see it in the back, but he's pointing at something labeled no data. And this was Wayne's effort to convince the Navy to invest in an oceanographic vessel and measurements along the Newport hydrographic line, which sort of started it all. And so we're trying to fill that no data gap. So hence ocean observing. So here's one way to do it. Oscar Schofield runs the Rutgers lab and sent this to me. Okay, so for years we've been using ships. Grand tradition, right from the days of Challenger. I was just explaining to the class how the diel vertical migration was definitely noticed on the Challenger expedition. Through the early days of steam and diesel, the venerable Wacoma, and then we're all looking for the Ta'ani coming online in 21, 22.
I like the reef that they did on the Atlantis. It looked a little different the last time she was in here.
Yeah, so Bob Cowan just sailed on Atlantis 2, not Atlantis 1. This is another one of my favorite quotes. Anybody know who Hank Stommel was? Somebody? Arguably one of the two greatest physical oceanographers. Well, maybe there's more than that. Recent ones. Henry Stommel figured out how the Gulf Stream works. So we knew for a while from Sverdrup that there was a circulation around the gyres. I guess I should go this way for northern hemisphere. But nobody knew why it was stronger on the western boundary, why the Gulf Stream was stronger than over near the Canarias, or why the Kuroshio is stronger than the California current. And he wrote down the equations that showed that it had to do with the rotation of the Earth and why it needed to be stronger on that side. He and in the middle part of the last century, there was a lot of theoretical work going on and how the ocean worked, and Hank was a great contributor. Okay, so I'm going to talk about a mixture of platforms. I'm going to talk, vessels are super important. We need to get stuff out, get it back. I'm going to talk about moorings and some newfangled ones that go up and down. And of course, I can't give a talk without talking about these underwater vehicles that we use in our lab. So let's start off there, just to get that one out of the way. So we can now use autonomous underwater vehicles to do our basic physical oceanography and a little bit of chemical and biooptical measurements. So these are fully autonomous, no propellers. They propel themselves by buoyancy. So they inflate, not inflate, they actually push a piston out, make the volume bigger. That displaces more water and they go up. And they just pull that back in, smaller volume, and they descend. This is a 200-meter version. There's a 1,000-meter version that pumps oil instead of a piston. And a couple of wings on the side cause it to glide up and then glide back down. And they're slow. They go about 15 centimeters a second, about like that. But they just go and go and go. This version can stay out for 3 weeks to a month. And the deep version we have can stay out 6 months, and the record now is about 11 months. And the reason it can do it is because it's slow. A propeller-driven AUV is great. It can go 4 knots, but it burns itself out in 12 hours. So the key thing here is to go slow. And that actually helps you when you hit the bottom accidentally. There's a pinger out here that we say, turn around before you hit the bottom. And we typically go 3 meters from the bottom, so this light height to the bottom. And we put a whole bunch of instruments on it: chlorophyll, colored dissolved organic matter, light backscatter for particle load, temperature, salinity, dissolved oxygen up here in the tail. And we command it through an Iridium cell phone and get the GPS location. So we can basically send them where we like. They're slow. They can't fight the currents completely, but we kind of go with the flow sometimes. This is just an animation of how they work. So we set up a waypoint file that it tells it where to go. It swims underwater and then it surfaces and phones home, calls us. We tell it where to go again, or if we don't want to change it, it just goes about its mission. If it comes up at a location where we told it not to go, It's because the current moved it. And we can calculate the current from that. That's called dead reckoning if you're a sailor. You want to go over there and you end up over there because there's been a cross current. So that's a really useful tool, and actually that's how Benjamin Franklin made the first maps of the Gulf Stream. He took the dead reckoning records from the mail boats going to and from Europe and mapped the Gulf Stream that way. Our lab has flown these off Newport for many years now, back and forth on the Newport line. Here's NH1, 3, 5, 10, 15, all the famous stations. Wonder what that sound is. Anybody know? Haley, do you know? I wonder if one of my...
Or if it's folks over at construction, that Marine Studies building. They've been counting, the building's been shaking all day.
Can't blame that on me. Okay, so we've been out for just through January 17th for almost 5,000 glider days. We've collected 290,000 profiles up and down, and it's the equivalent of 107,000 kilometers. And just for some comparisons, I went back to the archives off Newport, and there were only 4,000 profiles from 1950 to 2005. It's kind of mind-boggling, isn't it, how much more data there is now? So we're actually hosting a session at the next Pisces meeting on machine learning and how you use data and use computers to make decisions, look for patterns. And I know that others of you are looking at pattern recognition in video samples. Is it only me that can hear that? Okay, here's the, I think it's one of my, yeah, there we go. Thank you. So the last comment is that that distance is equivalent to over 2.5 times around the planet. And this is only basically one glider. It's two of them. We swap them in and out. So when our lab started, we got serial number 33 of one of these guys. They're now up to almost 1,000. That's just one company. There's at least 2 or 3 more companies now, and it's really becoming the way to do profiling in the ocean. And you discover all kinds of cool things. This is just an oxygen section off of Newport where you can see the blue colors correspond with the crab die-offs. Okay, so that brings me to the Ocean Observatories initiative. And this is something we started, really the discussion started in the early 2000s. I got involved in about 2002. We held a big meeting in Puerto Rico in 2004 where the first plans were put on the table. And now we're, 15 years later, and we've got this built and operating. So it's trying to put sensors in the water that are there permanently, and we can work with them interactively over a range of parameters. And again, similar motivations around coastal dynamics. We also are interested in the high latitudes with some of the bigger buoys that are up in the subpolar gyres. And it was pitched to NSF, and they funded it through what's called a Major Research Equipment Facility Construction Grant. We build it in 5 years, and then we're into this operational mode. And we stressed that we really needed to keep it going for decades because of all the signals out in the ocean that are 3 to 5 years and decadal. So if you just measure for a little while, you're not going to see all those changes. Okay, so I'm going to talk about the endurance array. And I'm here representing a huge team of effort. My colleagues Ed Dever is the lead on the installation and operation, and John Fram is our lead system engineer. And then about 15 to 20 other people are involved in the project. I've mentioned these science drivers already. So this is just a diagram of part of the array, and this one emphasizes the cabled part of it. So this is a partnership with the University of Washington, and we're hooked to the cable, we being OSU, the Endurance Array. That's our area here, but we're hooked to a cable that's come offshore at Pacific City. So anybody been to the Pelican Brewery in Pacific City? Just a little bit south of that is where we landed the cable. So here it is being installed. Pelican's over here somewhere. And we used a old landing for a telecommunication cable that's going to Asia. So it was the cable was bored through the seafloor, came up right here, and we essentially hooked it to the internet in a sense. And that vessel, which I think is a 600-footer, it's a cable-laying vessel, plowed the cable 4 feet into the seafloor, out to 1,000 meters, and then it's just laying on the bottom otherwise. And it's a big, fat, armored cable with a bunch of fibers in it and power. And it goes out 500 some kilometers to axial, makes the turn, that's the one leg, makes the turn and comes south and all the way up to what we call NH10, 10 miles offshore of the Newport line. We purposely did not come all the way to shore here because of the big waves and sand movement in the inner shelf. So just this alone took a ton of work to get it, the communities comfortable with it, to get it permitted, to get it installed. But that was done by 2011. Then we started building all the infrastructure on top of that. So the Endurance Array consists of a heavy set of moorings off Newport, another set off Grays Harbor, and then a network of gliders, not just working on the Newport line, but the Grays Harbor as well as the other lines. We basically wanted to be both sides of the Columbia to see the ecosystem effects on either side. There's 20 types of platforms. The Endurance Array has 240 sensors on it. And I want to stress that they're very different. Everything from simple temperature sensors to PCO2 and pH sensors, cameras, video, acoustics, etc. So this would not be a huge number if it were just temperature sensors. I mean, I've personally put out a small mooring array with 100 temperatures, no problem. That's fairly straightforward. But it's the heterogeneity of all these sensors that's different. The cabled part of our array has 39 sensors on it. And we argued for placing these here because of the historical data that we had, that many of you helped collect. So if you look sideways at that Newport line, it looks like this. So Yaquina Head's right here. You go out 25 meters. This is the Oregon inshore mooring, 25 meters of water. It's got a profiling mooring as well as a surface mooring. This guy is designed to go underwater because year-round we know that the waves get huge there. And it had to be capable of withstanding that. So there are no fancy MET sensors or anything on that. It can get dunked. And this line here is a stretchy cable. It can stretch to twice its length. So in 25 meters of water, we know there's 10-meter waves. So it's going to stretch like that. If you don't do that, the mooring will walk. Every wave it does this. And it'll end up in Vancouver Island pretty quick. Okay, the mid-shelf is supposed to look at upwelling fronts and jets. The unique thing here is there's a hook to the cable, an underwater platform. We call it the Benthic experiment platform. And then further, we wanted to go out to the slope and look where the poleward undercurrent going this way delivers different water properties to our shelf. And there's a ton of stuff out here. And then even farther offshore, there's some more moorings maintained by UW. And these are just the names when you jump on the site and you search around, you'll see us use these names: Endurance, Oregon Inshore, Shelf, and Offshore. There's a similar line off of Washington, except it's completely autonomous. There's no cables hooked to anything. We weren't able to afford to make that cable run. We had to make some compromises. But the moorings are the same, except they bring the data to shore exclusively via satellite or cell phone. The glider still occupies that line as well. And then I just put up a bunch of the kinds of sensors that are out there. So on that profiling mooring that goes up and down, regular CTD, dissolved oxygen, photosynthetically active radiation, chlorophyll A, we've got CDOM, point velocity, we're measuring the nitrate, the spectral irradiance, the spectral optical attenuation and absorption, so we can get down to the pigment values of what's in the water. And I should have said right off the start, all this data is available to you. It's not my data, it's not Ed's data or John's data, it's your data. We were supported by NSF to be a community resource. Then out here on the mid-shelf, we've got multi-frequency acoustics, bottom-mounted looking up. And we've matched the frequencies, the SIMRAD frequencies, to what are used on the ships, so we can do comparison between ship surveys and point measurements. We've got some deep profilers on the offshore, just tons of parameters that you need for a ecosystem study. And this is from the UW graphics group, just looking back onshore. So I've been talking about the shelf array out to here, but there's also the Hydrate Ridge Observatory, and then the slope base having even more measurements. So off Newport, you look out there, bunch of blue ocean. This is probably one of the best instrumented places on the planet. We should feel pretty unique about that. Okay, so here we go, Haley. I'm going to try this. I want to show you how we put this together. You think it's already playing behind there? I'm going to let her do it. So this is just the time lapse which you saw when you sat down of putting the moorings together. And I'll just show you a couple of the pieces. Oh, it's on the other one. So this is our Ocean Observing Center in Corvallis. It's on 99 West on the south end of town. Is it working? Yeah, slide it over. Yes. Get it started though. Start it at the beginning, please. Okay. So we have a custom outfitted facility over there. These are the big bottom anchors in a sense. They're instrument packages. These are the wells that go underneath the buoy. In OOI, everything is big. I mean, these are huge buoys, and they're meant to last for decades and withstand the winter storms. We hired a technician from Pisco. Pisco's looks at the inner shelf. We put in little tiny moorings, and my favorite picture of Tully is he's got a little shackle about this big and a humongous shackle that's this big. And so it's Pisco and OOI. This is one of the instrument packages that's going to be hanging 7 meters down. It's loaded with sensors. And so this is the activity that happens twice a year as we build up the moorings. Notice how everything's fresh and clean and tidy. Okay, so what should I do? Escape it? Wow, this is going to make this hard on me, man. And then replay this. Okay, super. So you get it all made and you put it on a flatbed, drive it out to Newport, put it on the dock out here, and then you have to put it on board the vessel. So let's do that. it so I can see it. So for a couple of days we load the vessel. So you may have seen the giant buoys out there, and these are the anchors on the bottom. This is on the Sekuliak, the University of Alaska Fairbanks vessel. So we're going to try to put more than one of the moorings at a time in here because the ship time's expensive. We're going to go out, deploy it, come back, load up some more. This is one of the big surface buoys. The blue guy has anti-foulant paint on it. The ones without are going out deeper in the ocean. Again, everything loaded up with sensors. Okay. And then you get stuff all loaded and you deploy it. So let's just take a peek at that. Now I'm getting confused. Where am I? Deploy. Yeah. Sorry, guys. Okay, let me try this again. Okay, cool. This is our last one. Okay, so this is the initial installation of that mooring off Yakuna Head in 2014. I'll just let this play. It's a minute long. So we took two vessels out that day, the Pakstorm and the Alaka. And we had on board one of the surface moorings. That's the one that can be submerged in the inner shelf. You can see we had some drone footage too, which was cool. Typical weather. I'm on this one, by the way. We launched a glider right nearby. This is a really cool shot. So the surface buoy went in, and now we dropped the anchor all the way to the bottom, do an acoustic release, and just set it gently on the bottom. And then stand off and talk to it for a few minutes, make sure it's working okay. And then here's the glider that we launched from Alaka. This is harder than it looks. Close tabs. Okay, sweet. All right, you put stuff in the ocean, and this is one of the biggest challenges. What are these things? We got some mussels. We got a barnacle. Barnacles are right. What species? Huh? Yeah, I think so. Anyway, it can be a real mess. Here's one of those guys that go up and down. This is before we learned how to treat it better. But one of the cool things we're doing now is we're using UV light to fight the biofouling. So here's one of those instrument packages that nice and clean in the lab. I show you it was being built. It gets put in and get completely covered. In fact, this oxygen sensor right here, that's going to be tough to make a good measurement from that. So John Fram led the acquisition and installation of some UV lights. They basically point at the sensor head, and so the black is unprotected and the red is protected. This is oxygen going here over time. So you can see the diurnal growth cycles when you don't protect it. So this is a constant battle that we're working on. All right, let me give you a flavor for some of the data. This is from, again, the inshore Oregon mooring. It's just showing the oxygen here in red and the temperature in blue back in July of 17. And we collaborated with ODF&W on explaining some of the deaths of the crabs in the nearby crab pots due to a hypoxic event. But here you can see that you're above a hypoxic threshold, and then you just descend down into hypoxia. And just that few days is enough to affect the organism really drastically. So we're able to keep track of that. Another fun one is that we had a once-in-a-lifetime eclipse happen while the array was out there. And not only that, it came right over the top of the array. So we couldn't have designed that, I guarantee you. But again, we were able to use the assets to look at how the diel vertical migration of the zooplankton was affected. So this is a acoustic backscatter from out on the continental slope. You can see the regular night-day migration. And then here we are coming down and the eclipse goes over. This is the killing off of the incoming solar radiation, and the zooplankton start to come up. They actually start their way up, and then they go, oh crap, that's not right. Back down, and then back up again. But you know, everybody where I was in Corvallis, we were all listening for the birds and this and that. This is happening in the ocean. Seeing beneath the waves, we can get the full depth of the warm blob. Everybody's heard of the warm blob in 2014-15. That's just the satellite imagery. But with the offshore Washington vertical profiling mooring, we can get down to 500 meters and get the whole upper ocean heat content. So the warm blob was pretty shallow, really. But then it was followed by an El Nino, which you can see penetrates much deeper. A little bit of a respite in the 2016 summer, and then continuing on into the warm years. Okay, so how do you get to the data? You can go to our oceanobservatories.org website. Please try that out. There's a whole bunch of stuff on here. If you go under Observatory, it'll show you all the different elements. You can pick out what sensor you want to look at, that kind of thing. Go to that data portal right there. And then there's a pull-down menu. And you click on that thing called the data portal. And it'll bring up a plot like this. There's a map. So here's the Oregon line. Here's the Washington line. Here are the gliders. And there'll be a list of things that you can choose from. So I'm going to choose the Oregon inshore mooring, which is right off Yaquina Head. This guy here. So I'll click on that. And it'll just list off all the sensors that are available to me. So I'm just going to pick a simple one. Here's the CTD. And it's at the surface buoy, 7 meters down and on the seafloor. We've got several of them. And then I can go in and ask for data between particular time windows and that sort of thing. Okay, so that's how I do that. And here is the result. And I'm sorry that it's a little bit faint on this thing, but maybe you get the sense. This is the last 30 days. So this is the 17th of July here. And we've got temperature and salinity at the bottom. And you can see the blue, you can see the cold upwelling, a reversal, back down to cold again, and then the more recent calm wind period. You can for sure see the tides in here. So if you grab the data, it's going to be raw. You're going to have to filter it to use it the way you want to. Right near it is a dissolved oxygen sensor. So we can, and the numbers here are micromoles per kilogram. That's 0, that's 100, that's 200. So in the inner shelf, there's a lot, especially when there's these reversals, there's lots of oxygen. It's not going hypoxic there now. We'll see what happens in another month or so. Okay, I wanted to show you there's a different way to get the data, and that's by something that's called an ERDAP server. Anybody recognize that term? Anybody do that? It was started up and invented by the NOAA group down in Monterey Bay the Environmental Research Division, the ERD in ERDAP. It's a super simple interface to get a hold of data and plot it and subsample it, things like that. It's become almost the de facto standard in the NOAA oceanographic community. So it's another way to access the data. And John Fram provided me with an example of using ERDAP to look at the profiling mooring data. So 4 times a day, this buoy is going up and down with a sensing package. So this is from here's the 1st of July, almost the 1st of June. And it's color-coded by the oxygen levels. The greens and reds being high. So again, you can see those upwelling and reversals and upwelling, but now you're getting in the whole water column. So we can do that from these profiling moorings and also from the gliders. This guy goes up and down. Okay, so I'd like to encourage you to try it out, grab some data. I should say that whenever you make a plot like that, all you have to do is click download the data and it'll come your way. So Ed and John and myself, others will be glad to answer questions. And if there's a group of people that want us to do a really drill down in particular, like a sensor or a mooring or something, and you want us to help you do all that, please ask and we'll come help. All right, I don't want to leave without explaining what IUS is. So I've just talked about the Ocean Observatories initiative. There's a whole other ocean observing effort called the Integrated Ocean Observing System, IUS. It's funded by NOAA. OOI is funded by NSF. It's for basic research and technology development. NOAA is mission-oriented. So they were funded and brought up at the same time. And I was at a lot of those meetings in the early 2000s, and we had a heck of a time explaining the difference between OOI and IOOS. Like I sort of think I know what it is, but if you take that idea to a senator, you know, OOI, OOI, IUS, what are we doing here? So we had to work really hard to figure out those 2 different missions. And NANUS is the one that we formed in 2003 for Oregon and Washington. So who's heard of NANUS? A few people? Yeah, cool. So it's one of 11 regional associations. So here's NANUS up here, Alaska one, Central California, Southern California. There's a whole bunch of them. And they all try to work together to make data useful. Our particular interests up here are in ecosystem assessment, fisheries and biodiversity, coastal hazards, and tons of partners. I don't expect you to read all these, but the green is governmental, the black is academia, red is private industry, and blue is NGOs. So a whole bunch of people getting together says, we want to be part of this. So there's also a NANUS web page there. They have a cool visualization system. You can punch on a bunch of the land stations. We actually put the OOI data up there, so you can get it there as well. And I'm just about done. This is a really nice app that Craig Rissian made. It's a climatology app. So it takes the averages over time, seasonal cycles, and then it subtracts that out and gives us the anomaly. So this is June's North Pacific temperature anomaly. Not so good, huh? It's still warm out there, except for us. We got some good upwelling. Not so good in Central California. I think they've been having some real challenges. Okay, a while ago, a bunch of us were involved in something called Pakus. I don't know, maybe Bruce was or some others. I was on the governing board for a while, and we were going to put a ton of lines in the California current. Never happened. It's expensive to run ships like that. So a bunch of us said, well, why don't we do it with gliders? So this was our suggestion in 2008. We might do, here's the Newport line, we're already doing that. These are the so-called Cal Coffee lines. So not an organized effort, but we just kind of each worked away. And we're almost there. This is another amazing thing. Our coast, the West Coast, is probably the best observed with gliders. So the stuff I've been doing, we have a new line on Trinidad Head. This is the OI and Newport line. Dan Rudnick is occupying these Cal Coffee lines. And we have one more planned for off Bodega there. So this is the perseverance story, right? If you got an idea, just keep trying. You'll get there. So last couple data slides, you can use those gliders to keep track of the temperature anomalies. So this is just a plot over time going this way offshore, going from cold to warm regimes. You can look at it in depth and then keep track over time. And we made an index. It looks like so. And I should attribute this to Dan Rudnick, my colleague down here. This is glider data now in the blue. It's just an index of how much warmth is in the upper layer. And then we added on the Trinidad Head one in magenta here in 2014. And then we compare it to the Oceanic Nino Index. So you can see that the big El Nino of 15, 16. Here's the warm blob. It's got nothing to do with the El Nino Index. But I think what I really want you to see is notice how it's lowish here and it's staying high. Even though the El Nino Index is back down below, it wobbles around 0. We haven't gone back down. So the warmth remains. Okay, I'm going to skip this next couple and just take some questions. Thank you. Oh, I want just one more quick thing. The one I just skipped is this guy. I put it up over here. So notice it's got the OOI and the IU stuff, but now we've got most of Canada as well. Huge effort going on with stations on land run by communities, the Native American tribes, the First Nations. Everybody's really kind of getting together in this observing community. Bruce.
Can you tell us, sort of, with that trend of warming, what's happening with the zooplankton base, I guess, and what you would predict would be the trophic consequences of
That's
that
one.
that continues?
Yeah, that was one of the ones I skipped. So we know that the layering leads to all sorts of stuff. So you warm that upper layer, you do a couple things. You cap off the ability to get oxygen in and out of the water. You also form a more stable thing for plankton blooms to be favored. You know, the NH line work here on looking at copepods show us that there's changes with warm and cold in the different species. So I think we're just going to continue along that direction we've seen the last couple of years in more of that warm regime and those ecosystem consequences.
Their concerns, of course, for blue whales,
Yeah.
particularly set on just certain kinds of things each, you know, and so when you see big change like this developing, it seems like it's going to have some
Yes.
ripple effect.
Other questions? Yeah.
Yeah, so how much did how much did it cost? Both to build it, all its components, and also to maintain it?
That's a great question, Gil. So whenever I show those gliders off, and they're all so cool and everything, either the first thing people want to know is how much do they cost, or they forget to ask, and then I have to tell them to ask. So thanks, Gil. The whole OOI array was the biggest investment civilian in oceanography ever. It's $385 million. Okay, and it runs every year. The piece that we get for our part is about $7 million per year. So it's a big investment, and it's meant to have this underwater observatory for all of us to use.
Okay, so the second part of the question was, I think it was a group from DC came out here about 8 years ago and interviewed folks about the OOI. It was more of a public
they interviewed a bunch of us here. But the sense I got is they were looking at, and you said, how people could use the data, how they could enter it, but also how they could contribute to the data. So it wasn't, if I understood correctly, it wasn't just for the major oceanographers. It was also for citizens and other groups that contribute data, even a high school class.
Exactly.
So I just
Yep.
wanted you to comment about that.
Yeah, so early on when we were talking with all the coastal communities to find a place to put the gear, we explained that we wanted to make the data available so fishermen could grab it, look at the depth distribution of temperature, or they might be interested in the bottom currents. That's the thing you just can't get any other way. So we're trying to encourage that, make it easier for them to get that. By contribute, I think there's contributions in analyzing the data, looking at the data. It's taking it off those platforms into the classroom. We want people to hook up new instruments or think up new things to do. And that is happening on the array, where somebody has a new copper sensor, say. They can try it out on our array.
But not contributing data. Is this something else they have proposed to us or said that's?
Yeah, that's where we get more into the IUS world, I would say. Remember, I've showed you all these. So these are individual communities that have CTDs on the end of a dock that are contributing data to that whole network.
That network.
So the OOI, in a sense, is a contributor to this. Yeah. Yep.
So the NSF funded a lot of this, thinking of the Grays Harbor line and the
Yes.
Newport line. Is there going to be an overall assessment of the different, I mean, I'm interested in North and South of Columbia like everyone else. Is there going to be an overall assessment of results eventually, or we're going to have a book out of this? I mean, I know there's loads of data
Yeah.
that individuals have to look at.
Yeah.
Will we have some kind of generalized summary that we can refer to from this?
So first of all, the data's there. You're welcome to do a comparison, north and south.
I want you to
Go
do
for
it.
Well, we're all working on our science projects. Of course, I'm super interested in the heat content and what the gliders are showing us. But we want people from Humboldt State to use it, and Evergreen, and everywhere else. I hope that will be exactly what you're talking about.
Eventually.
Yeah.
So how much does a glider cost?
When I started, they were about 70K, and they're up to 150 to 200K. And like I explained to the students, that's your entire college education, right? 4 years at a school. It's also like about 4 Mercedes-Benz. But to operate one of the large research vessels is 25,000 a day for the Oceanus, and the Atlantis 2 that Bob Cowan's on right now is probably closer to 50K a day. So in 3 or 4 days, you make up the cost of one of the gliders. Other questions?
So Jackie, that raises to me a kind of interesting question about the difference between this rigid fixed systems like the underwater observing system versus the more flexible individual components that you highlighted with the ABB. Looking a decade or so in the future, where would you put your money and time?
Yeah, great questions. And I was right in the beginning of that when we first pitched this to NSF. They could not get their heads around the fact that we wanted to have mobile platforms. They were so used to funding telescopes or the big physics experiments that were one piece of stuff in one place. And it really took a huge effort for us to get any of this mobile stuff in here. I think, my own bias is those mobile platforms are so important, but we can't catch zooplankton with them, right? We can't do a lot of the basic chemical and biological oceanography, so we have to supplement it with either fixed stations or ships. But I think in the next generation, you're going to have sensors for doing all sorts of stuff from those mobile platforms. Somebody over here? How about an REU intern ask a question? Put you on the spot.
integration of the new autonomous sailing drone.
We're not doing that, but NOAA is very active in trying that out through the Seattle lab. In fact, they're thinking about it down here as well.
Some years ago, Jeremy Childress, who was a
MRM student.
MRM
Yeah.
student, thank you, that's what I was looking for, put together a test case for using submersible dissolved oxygen meters that he employed the crab fishing industry to deploy, a tiny number of them.
Yep.
And he's been talking lately about an expansion of
Yes,
that.
that's correct.
And do you have an update on that?
Yeah. So that's actually a grant that Francis Chan and myself and Jeremy and Dave, I think, are you on that one? Steve and Dave are on it. Who else am I forgetting? Kip's on it, Kip Sherman. Anyway, a group of us went to NOAA and said, that's a great idea, let's try to do more of it. And further, we have Will White involved too, so we want to use the information about how it affects the stock assessment and the fishery assessment. Like, for example, if you measure in an area and you catch no fish, is that because it was hypoxic, or were there no fish because they're not abundant? So yeah, that's citizen science, or finding ways to get stuff out there is important.
That's a project that is...
It's happening.
Yeah.
Yep. Okay. Thanks for coming. I'll stick around, take a look at the map.
With this, can you see the patterns of planktonic blooms over time?
Yeah.
So you can see if there's a match or mismatch with feeding for certain species?
Yeah, the only problem is we don't have the fish